Hello everyone, welcome back to my channel Muskan Psychology Network, and today we would be learning about factor analysis. For the ease of learning and understanding process, I have divided this module on factor analysis into three parts, and this is just the first part. All the subtopics which you would be learning are what you can see in front of you. As far as I know, at the master's level, if you have a statistics paper, if you have psychology as a core subject, you're definitely going to have a statistics paper, and factor analysis is a very important part of it. If you take an advanced statistical course as your optional paper in maybe your third or fourth semester, then definitely you're going to learn more in depth about factor analysis. So, whatever the topics you are being taught in your master's level, or even after that or before that, whatever it is, you can find the subtopic here. If I have missed anything, please do let me know in the comment section down below. Now let's start with what is the definition of factor analysis. I always hammer on a fact that statistics is there for understanding and not just mugging up. But in few cases, you do have to learn up the definition for your own easy understanding. I believe so, and it has helped me understand what factor analysis is when I was studying. So let's see this definition very closely and harp on your basically the phrases which you can see in different colors, especially try to understand and learn those up because these are important. Proper use of words are very important in factor analysis, or there will be a lot of mix up happening. Now let's read this definition, which is factor analysis is a multivariate statistics which is used to know the latent common components of the manifested variables when there is an interconnection among the components. Now, what is manifested variable? Manifested variables are variables which you cannot observe, but you can definitely measure them. There are a lot of manifested variables in the psychological domain, if I have to say. There is your intelligence, there's your personality. Now, personality, you cannot observe it, but you can definitely measure it. There are a lot of ways to measure it. You have your projective tests now, which you have a lot of, what do you call those? Tests, pen and paper tests. You have those. And for intelligence, you have your IQ tests. Now, what are the latent common components? The latent common components are explaining the manifested variables. Suppose the IQ test that is being used to test your intelligence. Now, the latent common components could be your logic, it could be your numbers, comprehension, then you have your non-verbal tests. Now, all these are your latent common components, and these will definitely have some interconnection among the components. Now, there can be two, three, and more manifested variables, and for all the manifested variables, the latent common components might also be same, but the amount they are describing that particular manifested variables would be different. You would understand that as I move forward. Till now, what is factor analysis? It is used to know the latent common components of the manifested variables when there is an interconnection among the components, among the latent common components. Now, factor analysis is a dimension and data reduction statistics. Why is it called a dimension and data reduction statistics? Suppose in the literature, there are 100 common components for one single manifested variable. Okay, but can we always, to explain that particular manifested variable, talk about those 100 latent common components? No. Maybe one latent common component is explaining only 0.3% of that manifested variable, and another is explaining about 5% of the manifested variable. So we would definitely choose the one which is explaining 5% of the manifested variable. We will choose of course there is a particular way of choosing, but just for the ease of understanding, suppose from 100 the first 10 common components are explaining the manifested variables the best. Suppose it is explaining almost 98%, 98 to 99% of the manifested variables. So we would choose those and discard the others. When we are discarding the others, the model is becoming more compact. We will not be working with those 100 latent common components, but only the particular 10. So it becomes easier for us to work. So that is why it is called dimension and data reduction statistic. As I said, manifested variables are measurable but not observable. We cannot see intelligence, but we can measure it through certain tests, which are usually your IQ tests. Now, these are one of the examples which I have taken from the field of psychology. If these are your manifested variables, these are your latent common components. Okay, and suppose insecurity, emotional lability, fearlessness, shamelessness, shamefulness, depressivity, all these are interconnected, and these are able to express neuroticism. Here, suppose if data reduction dimension data and dimension reduction, if you take in here 1 2 3 4 5 6 7 7 latent common components, here we are working with for neuroticism. Suppose neuroticism can be explained with other 15 as well, but very low percentage. Maybe it's explaining 0.54% of neuroticism, but helplessness, insecurity, these are explaining like suppose 6% of neuroticism. Just making up the percentages, but to understand why is it being called data reduction, we cannot put more 50 latent common components here just to explain neuroticism. If these are able to explain, these 7 are able to explain neuroticism pretty well, we will not be taking the other ones. Okay, now this is another example. You can pause and read it on your own, and you would understand this. So I would be moving on to the different section, which is the uses. The first use we have already come across, which is the variable reduction, which is your data and dimension reduction, and your scale development and evaluation of the psychometric quality of the measure. Scale development, your second, and the assessment of the confirmation of dimensionality of a set of variables. You would understand this later, but for now, just learn that it's used for variable reduction to make up a scale, even for model building, and the assessment of the confirmation of dimensionality of a set of variables. The first definition was what is factor analysis. Now you have understood what is your common latent components. You have understood what is manifested variables. Now those latent common components, the underlying dimensions, those are called factor, and they occur for several manifested variables. Okay, now consider these as your manifested variables, which is momo, chowmin, and cake. Flour in some percentage is in momo as well. Maybe 15% of momo is made of flour, maybe 45% of chowmin is made of flour, maybe 60% of cake is made of flour. In momo, maybe there's only 2% of egg. In chowmin, there is 15% of egg, and in cake, probably again there is 8% of egg. Now, these are your manifested variables, but you see, flour and egg being a factor are occurring in momo also, chowmin also, cake also. Flour and cake is your factor. Common components, latent common components, the other word for it is factor. Now, flour and egg is your factor here, and these are occurring for several manifested variables, several momo, chowmin, and cake. But the percentages is different. Okay, moving on. What is factor loading? First definition, factor analysis, then comes your latent common components or your factor, then is your manifested variables. The fourth definition is what is factor loading. Factor loading is the interrelation between the latent variables and the manifested components. Factor loadings are those values which explain how closely the manifested variable is related to each one of the latent variables discovered. Now remember I was talking about maybe 8% of your cake is made up of egg. So in factor analysis, we don't use those 8%. Percentage is not used, but it's almost like 0.34 and 0.68, something like that. And the factor loadings cannot be more than 1. So here, as per my example, if I take egg is explaining 8% of that cake. So how closely is the egg related to the manifested variable, which is the cake here? That how closely a latent component, which is a factor related to the manifested variable, is your factor loading. Now in factor analysis, factor loading is how close it is, how close the factor is to the manifested variable. Simple as that. And here the factor loading cannot be more than 1. uh, we can see here that there is factor loading of factor 1, 2, and 3. Now, manifested variables are your 1, 2, 3, 4, 5, 6, 7. And for the 7 manifested variables, we are considering here 3 factors. Now, you see these are your factor loadings 0.593, 0.612, 0.618. These are your factor loadings. Okay. Now, for your 5th and 6th definition, which is very important, is your commonality and eigenvalue. Commonality is the summation of squares of factor loadings of all extracted latent variables of one manifested variable. Here, this one is the commonality. Commonality is the summation of squares of factor loading of all extracted latent variables associated with only one manifested variable, and commonality is measured in terms of variance. Now, if you have difficulty understanding what is variance, that is something you have to look up your book for, because variance is something you will be talking about and learning about in your entire statistics paper. It's a very important part of statistics and basics, almost the basics of statistics. So please understand what variance is and how commonality is being measured in terms of variance. Again, commonality is the summation of squares of all the factors here, factor 1, 2, and 3, for one manifested variable, for only one. See, but eigenvalue is the complete different. I wouldn't say complete different, but opposite, which is eigenvalue is the sum of the squared values of factor loading of only one factor for all manifested variables. Commonality is the squares of all the factors for one manifested variable. Eigenvalue is the sum of squared value of all the factors for all manifested variables. You might take some time to understand this, but quite easy, and take your time to understand it. Once you understand it, the next slides will be even easier. Now, this is just showing what commonality and eigenvalue is from this previous example. So this is just, they are squaring it up and then summing it for the commonality, which is all the factor loading of the 3 factors for one manifested variable, and eigenvalue is the factor loading of only one factor for all your manifested variables. I would be stopping my part 1 here, and this second part will start from steps of factor analysis. Thank you so much for listening, and if you have difficulty understanding, I would say repeat the video as many times as you want, and it would make it easier, because factor analysis is not a very easy topic, I would say, but definitely once you understand the basics of it, it becomes easier in the further